This is going to be my second video to go over Chapter 7. If you watched the first video that I posted late last week, then that kind of went over the beginning of Chapter 7, kind of just the introduction to the normal distribution and how to use the normal chart, converting from x's to z's, then taking the z to the chart and finding the area. We also did one example looking at the normal CF. And so how to use the calculator instead of using the chart. So what we're going to start off with today is some more explanation of how to use the calculator, and then getting into some of the Chapter 7 problems that are more of the word type problems, and kind of explaining what that problem is really asking you to do, and so doing a few examples of those. But I wanted to just mention kind of where you should be at this point. Now, all of our assignments, Chapter 1 through 10, aren't due until the last day of the semester, which is Friday, May 8th. So you can work on anything till then, but these are just suggested dates. And so basically this is we started out the semester with. I just revised it a little bit. So it would say weeks and not days. But when we came back from spring break, we were in week 9. So right now we are actually starting week 12. And so it looks like, if we were in our typical lecture class, we would have taken test number 4 last week. So that means we would be moving into our last unit with Chapter 9 and 10. So if you haven't finished Chapter 7 and 8, you're not really that far behind right now. Sometimes in class we even go an extra day or two before we take a test. So I would say if you could try to get 7 and 8 finished or close to finished by the end of this week, you should still be good. Then you'll have week 13, you can do Chapter 9, 14, you can do 10, and then you can take the test here in week 15. Week 16, you can be preparing for the final and then taking the final. Also remember our final exam, of course, we won't be meeting to take that, and it's also not going to be proctored. So you'll just take that at home in the MyStatLab, like you're going to take your other test for Unit 4 and 5. And there won't be any password or anything. You'll just take it whenever you're ready. All right. So we'll have a practice final exam in my labs that you can work on, but I'll also probably give you the paper copy that we would have done if we were actually meeting together. All right. So that's just a quick review of kind of where you should be if you're kind of concerned about that. And also remember, if you do want to go back and work on any old assignments, you can do that. If you still have maybe some quizzes or something back from Chapter 3 or 4, you're still able to go back and work on any of those for full credit right now until the end of the semester. All right. Okay, so I'm going to go ahead and bring up this half of the practice test. So this says Chapter 7 and 8 review. So we're just going to cover Chapter 7 right now, the second part of Chapter 7, and then I'm going to do another video for Chapter 8. So this video doesn't end up being way too long. So the first thing we see here is a word problem, right? But really I think where we'll start is where we ended last time, which was talking about how to use the calculator. So this is going to be, these are my notes that I wrote out of some calculator help. Okay, so let me open up the calculator here. I can find it. Okay, so I've got the calculator up now so we can kind of see that as we're working through these. So the two functions we're going to use, and these are the two functions we'll use in Chapter 7 and Chapter 8, are the normal CDF and the inverse norm. All right, so you're going to use them for two different types of problems. The normal CDF you're going to use the x value, which could also be the z, but typically it's going to be an x, find that, And the area we can also think of as the percentage or the probability. So we could be finding, the top, we could be looking at or trying to find, what area is this, what percentage of values fall in this spot, or what is the probability that a value would fall in this spot. Okay, so it could be worded in different ways, but with all of these, we're given value. So you can see here, let me get this fixed here. All right, so when we're looking at this here, we know this value. Okay, so this one here, we've got a mean of 10, a standard deviation of 1. We're talking about a normal distribution, and we want to know what percentage of the data falls from 12.5 up. Okay, right, so from here to there. So what is the area? All right, so that's why we're using the normal CDF here, right? We start with the lower bound, so we're trying to tell the calculator what area we want, right? So we always look at the curve from left to right, just like we were reading a page, right? So if I'm talking about what area I want to start here, right, at 12.5. I want to go up to something, right? So I want to start at 12.5, and then we're going to go up to infinity. All right, so I think we talked about last time that the normal curve, the tails extend forever and ever. So they're going to go out from negative infinity over here to positive infinity over here. Now, because our calculator doesn't have like an infinity button that we can choose, we're just going to estimate what infinity is, which we can't really do, but we're just making a really big number, right? So in this case, we're going from 12.5 up to positive infinity, right? So we'll have 12.5. Our upper bound will be infinity, which we're representing as 9999, so almost 10,000, right? That's going to capture everything we need, right? Because we did already talk about with the empirical rule, once you're more than 3 standard deviations away, there's almost nothing out here, right? So it really wouldn't matter if we put in 100 or 1,000 or 10,000. It's still gonna get the area we need. All right, so I usually just stick with the 999 number. Okay, then we put in our mean and our standard deviation that we were given. So how we would put this in the calculator is we're going to go here and we're going to do second variables. So go to the distributions again, and we're going to choose the normal CDF. Now, for some of you, you might have where it comes up with the prompts, right? And so it kind of tells you to put in the lower and the upper bound. This one doesn't have that. It's an older version. But we'd put in our 12.5 and then a comma, which is there above the 7, and then our 999, comma, and then 10 and 1. That 0.0062. So remember, these areas are always going to be between 0 and 1 because we're thinking of these as either percentages or probabilities, right? And they're always between 0 and 1. So we could say this is like 0.6 data falls above 12.5. So we would say anything that did fall up there would be unusual, right? But that's how we use the normal CDF. And so I think we did that. We did a normal CDF problem. So now let's look at when or why we would use the inverse norm. So the inverse norm, really, we're trying to find the opposite. Okay, so the inverse norm is when you know the area, but you want to find the x or the, okay, so the mean of 10 and standard deviation of 1. So we're in that same distribution, but we're trying to find the bottom 20%. Okay, so now is right. We know it's the bottom 20%, but know what this is, right? We're trying to find, well, what is the x that separates that bottom 20%, right? Now with the inverse norm in the calculator, one thing to remember is that we're always going to put in the area to the left. So sometimes our problem will give us the area to the left, but sometimes it gives us the area to the right. Okay, so kind of like we saw in the first part of chapter 7 when we were using the normal chart was always the area to the left, right? So sometimes in our problems we may have subtracted from 1 and sometimes we didn't. So that's the same thing we're going to see here. But with the inverse norm, we put in the area to the left. Now this example, the area to the left of the value here is actually that 20%, right? So we put in 0.20. So this number should always be between 0 and 1 again. Okay, so if you get an error when you're putting in your values, make sure that you didn't put it in as a percentage or something else, so make sure it says a decimal. And then the mean and the standard deviation again, which are given to us, right? So if we go up here, we do distributions again. We go to inverse norm, which is number 3, and we put in 0.20, 10, and 1. And we get 9.1. If we rounded it to 2 decimal places, we'll say 9.16. So the lower 20% or the bottom 20% falls below 9.16, or you could say it's 9.16 or less, however you want to say that. And so that's how we'll use the inverse norm, and also how we use the normal CDF, right? So if we go to our practice test here, I'm trying to see, I think that actually was from the first part. Let me pull up the first part of the practice test. Okay, so yeah, this one was from the first part of the practice test, so it was number 5. And so this one would be one of our word type problems. So we have to figure out, what they're asking us to find, right? So the time taken to assemble a car in a certain plant has a normal distribution with a mean of 20 and a standard deviation of 2. What is the that the car can be assembled in a certain number of times, or in a certain number of time? All right, so first what we would do is think about, what are the important values here, right? So first of all, to know that it's a normal distribution, right? Then we need to know what the mean is, and we need to know what the standard deviation is, okay? And then we're looking at, well, what are we trying to find, right? We're trying to find what's the probability it would take them more than 23 hours to complete this car. Going back to here, so what I would do first is so we've got a normal distribution. It's got a mean of 2, and we're wanting to know the probability that it takes more than 23 hours. I want to find this area, right? So I know the x value, find the area, so that means I'm going to use normal CDF, right? We're going to start at 23 and go to infinity, so 23 and then 999, and then our 20 and 2, those were given to us. And that gives us an area of 0.0668. In a few ways, we can say that means there's a 6.68% take 23 hours to complete a car, right? Or we could think of it as 6.68% of cars at this plant will take more than 23 hours to assemble. So this is more of a probability, and this is thinking of as a percentage, how that data is distributed. The next thing it asked about, still the same distribution, but it asked how many will take between 18 and 22 hours. So 18 and 22, now and sometimes they'll throw one like this in where you actually could use the empirical rule. So if you notice, 18 and 22 are both 1 standard deviation away from the mean, right? The standard 2, so if I subtract 2, I get 18. If I add 2, I get 22. So if I'm one standard deviation away, that would be 68%, right, from the empirical rule. So you could use that if you noticed it, so that would be an acceptable answer. But if you didn't notice that and you were just, doing it in your calculator, we would still do the normal CDF, right, because we know the X values and we're trying to find the area. This time, because we have two values for X, those are actually going to be our lower and our upper boundaries, right? So we'll start with 18 and go up to 22. Then our mean and standard deviation, we get 0.6827. So you see that both of these are very similar, right? Both of them round to about 68%. Again, the empirical rule is rounded, right? So that's why you get a little bit of discrepancy there. All right, C says incentives are awarded to the employees that complete a car in a short amount of time. To get the award, the car must be assembled in the lowest 5% of times. So what time would qualify you for the award? Okay, so this one's giving us a percentage, right? Lowest 5% of times. So this is different from these two because these two gave us the time, right? They told us how many hours. This one, we're actually trying to find the time. So this would be one of those cases where we're going to use the inverse norm, right? So we know that it's the lowest 5. We don't know what the X value is, right? The area to the left, again on this one, because we're doing the lowest 5%, the area to the left is the 5, so the 0.05, then the mean and the standard deviation. And we get that you would need to assemble the car in 16.7 hours or less, right? So just as an additional question, how would we do the top 5%? Okay, so to do the top 5% of that same distribution, if we have the top 5, then we're looking over here in the right tail. But for the inverse norm, you're still going to put the area to the left. Okay, so the area to the left of the X for this one would be 0.95, right? We would do 1 minus 0.05, and that's how we get the 0.95. And then 20 and 2 still, that's still our mean and standard deviation. And so the top 5% of cars would take 23.3 hours or more to complete. So that would be one of those unusually long periods of time. Like if it was taking them that long to get the cars done, that would be unusual, right? Because we're not expecting that to happen very often. Let me see if there was anything else on this one. Yeah, okay, so we have just a few more for chapter 7. And I think that's what I started this one off with. So this one, again, another word problem. So we're looking at test scores. They're normally distributed with a mean 50 and a standard deviation of 175. They're only going to accept the people that score in the top 10%. So what score do you need to have to get into the graduate school? So this is similar to what we just did, right? So we're going to be using the inverse norm. This here. So this is the information that was given to us in the problem, the mean and the standard deviation. We're looking for the top 10 per area and we're trying to find the X. So we're going to use the inverse norm. This one, the area to the left is 0.9, right? The top 10% is the same as the bottom 90%, right? So we would put that in as our area to the left, 0.9, then the mean and standard deviation, and we get 1074.3. And depending on how the question told you to give your answer, sometimes it'll say round down, sometimes it'll say round up to the next whole number. So we're saying you need anywhere from about 1074 to 1075 or higher to be in that top 10%. Okay, and the very last thing that we see here for chapter 7 is a very short section at the end. Talks about normal probability plots. So what I want you to remember for that is normal probability plots are another way to figure out if we have data that comes from a normal distribution. So this is more of like a real life scenario. You know, when you've got data, you're not going to necessarily just know that it came from a normal distribution. You know, like when we look at our problems here, they say it's normally distributed, right? But in a real life scenario, you're not going to have that. You know, it's not just going to say, hey, you know, I'm normal, so you can use the normal chart and all that stuff. So the way we would figure it out is we could do a histogram, right? We could use a histogram, and the histogram, if it looked symmetric and bell-shaped, then that would tell us that it is a normal distribution. Sometimes with our data, we have not a lot of data, right? We may just have a sample size of 20 or 40, right? And if we have a small set of data, it's possible that when we try to do a histogram, we might not really see that bell-shaped curve. You know, maybe just because we don't have enough data, you kind of just a few bars and it doesn't really show if it's normally distributed. Okay, but that's not, just means we may not have enough data. So what the normal probability plot will do is, especially when you do have a small amount of data, it'll tell you if it's coming from a normal distribution or not. Okay, and so what it's doing, you don't have to worry too much about its plotting here, but this is something the calculator will do. Excel does them, StatCrunch, you know, so you wouldn't be doing this by hand. This would be calculated for your linear shape. Okay, so you're looking for dots that look fairly linear from left to right. And so this here, and so we would say yes, that we do think it came from a normal distribution. So if it looks linear, then we would say yes, it is normal. Okay, and so that's really all you need to remember from that section. There's not a whole lot in that one. Okay, but that's what we would do there. Now, if you are wanting to do it in your calculator, first you would go, well, turn it on. Then you would go to Stat and Edit and put some data in here. Okay, you'd have your values, you know, whatever data you're collecting in your list. And then you'd go to your stat plots here, like we did for our box plots and everything else. And this very last one here is actually the normal probability plot. So that's what you could use to create that graph and then be able to tell if it looks linear or not. All right, so I think that's all I've got for Chapter 7. So like I said before, the good thing is that Chapter 7 has the most material and things that you're going to need to learn and new information about how to use the calculator. Chapter 8, actually, you'll be using the calculator in the same way. So, you know, if you kind of can get that part down about how to read through a problem and know if you use normal CDF or inverse norm, then that will help you going into Chapter 8. Chapter 8 is going to talk about sampling distributions. And so that's what I'll do in my next video is I'll do a few examples of that. All right. So be sure to let me know if you have any questions. You can leave comments on the YouTube page if you want anything else worked out, or if you have a question about something I said on here. Or you can also just email me, of course, at angela.galloway@kctcs.edu. All right. So I will talk to you soon. Thanks.